Alright, welcome to Physics 30, and we're going to go through 3 questions. This is on the force and motion questions, the acceleration, speed and distance questions, and I had a request to do the last 3, and so here I go. I'm going to do these quite fast because you can always pause and rewind if you want, and I'll talk my way through it. I put the equations above the question just so that it's easy for you to see, and I can refer to it easily. But there's just really 4 equations and then one thing about gravity, and that's that it's 9.81 meters per second squared. So let's take a look here. Kyle dropped his 90s Sony Walkman from a window 3.50 meters above the sidewalk to Warren. Ryan, about the angry raccoon hiding in the garbage can. How fast is it moving when it crashes into pieces on the sidewalk? So let's take a look and let's do this. You could draw a diagram. I don't know how well I can do that. I'll draw it over here. So the diagram is basically there's a house. Alright, this is a good way to warm up. There's a house here, and I think I can change the color here. Boom. And here's Kyle inside here, little stick figure, reaching out, holding on to the Walkman's, and it's going to drop to the ground here. There you go. And Ryan's out here, walking around. And Kyle in here is trying to warn Ryan about the raccoon. This is not helping me to do this any faster. I'm realizing there's a raccoon. Can't you tell? Okay, so the distance here is, let's do it here. And actually I think I'll change back to that. The blue. Okay. So the change in distance, delta D, is equal to 3.50 meters. That's given. Nothing else seems to be given, yet there's a few things that are implied. And one is if you're going to drop something, that means that the initial speed that it is going is actually 0. Now if you throw something down or throw something up in the air, that's a different thing. So 0 meters per second. And it's not just one significant digit, it's an exact number. Okay. You don't know the final speed. In fact, that's what you're trying to find out. But there's one more thing. Anytime you drop something, it always accelerates at a constant rate. And we can say, because it's a constant rate, it's an average rate. So the average acceleration is actually going to equal the acceleration of gravity, which is 9.81 meters per second squared. Okay, and the last thing is, how fast is it moving when it crashes into the pieces? Now, you might be a bit confused here because sometimes you're thinking, okay, it just crashed, so obviously it's not moving at all. So the final speed is 0. And that's true finally, like whenever all the dust settles, yeah, it's moving at 0 meters per second. It's just there on the ground. But we're talking about just as it hits the ground, and so that speed there is not 0. It's what we call the final speed. And we don't know what that is. So that's how fast it is moving when it crashes to the sidewalk. Okay, so we've declared the things we know, the variables, and the variable we don't know, and now we got to think about what equation do we use. Now these questions are near the end of the worksheet, and they are much more difficult, and they involve actually some algebra. Well, all these questions do, but these ones specifically involve a lot of manipulating equations. And so VF, there's 2 equations here. Now, are we allowed to use this one? This is the change in acceleration is equal to 0. So if the change in acceleration is equal to 0, meaning there is no change in acceleration, which is true, it's a constant, it's always 9.81, so this is good. So then we can use this equation. So we can use this one, or that one. Now there are 2 that have VF in it. This one has VF and that one has VF. And just in general, I tend to gravitate towards the one that's the easiest looking one. If you happen to be wanting to find the average speed, and you knew VF and VI, or you knew the average speed and you knew VI and trying to find VF, then I would use this for sure. But in this case, none of the equations have the perfect amount of information. So we're just going to start here with delta V is equal to VF minus VI. Okay, and we're actually trying to solve for VF. So what does that mean? We need to rearrange the equation. Well, here's one thing that we should do right off the bat. I only recommend doing this if the values are 0, or if it can completely cancel out. So in this case, VI is actually 0. So I'm going to just say 0. And because of that, then delta V just equals VF. So I'm going to simply write this as VF equals delta V. Okay. Now the next thing we're going to do here is we're going to try to, well, basically you need to ask the question, do we know what delta V is? And nope, it's not given. So this one's already used. This one's already used this one. We can't use that again. So what other equation has delta V? This equation right here. So we're going to somehow use this equation, and we're going to substitute. We're going to first solve for delta V on this using this equation, and then we're going to substitute that value in for this delta V. And that's how you use two equations to create, to find an unknown. Okay, so we're going to rearrange this so it's delta V equals something. If we multiply both sides by delta T, we'll have delta T A bar is equal to delta V. So now we can simply take this and put it in for that. So now we have VF is equal to delta T A bar. Like that. Alright. Do we know A bar? Yes. It's good. Do we know delta T? No. So we've used these two equations, right, so far. Is there another equation that has delta T in it? Well, not this one, but this one does. So we're going to go to that one. V bar is equal to delta D delta T. We want to solve this for delta T and then substitute it in for the delta T on that equation. So there's different ways to do this one. The one that I tend to recommend to students is just to move things back and forth as easily as you can. In this case, most students want to multiply both sides by delta T, which is fine. That does not help to isolate delta T, but it makes it look like it's a more manageable kind of equation. And then we just divide both sides by V bar, and so you have delta T is equal to delta D divided by V bar. So now this we substitute into here. So we have VF is equal to delta D over V bar, all of that times A bar. Now we can multiply that out just so that it's all looking good. Delta D, A bar, divided by V bar. Okay. Do we have A bar? Yes. Do we have delta D? Yes. Do we have V bar? No. We have VI. So this equation now has been done. We only have this equation left. Good thing is it has V bar. It actually has it written in there, so I wouldn't necessarily have to write this down, but I will just to show which one we're using. Okay. And so this one, this value here, gets substituted in for this one, the V bar. So we have, I guess I don't want to draw it too far away, but I need room. VF equals delta D A bar divided by V bar. Oh, sorry. Where's my handy eraser? There we go. Divided by VF. Now I should go here. VI, that's 0. So it's just VF divided by 2. Okay. And this is this line here. If I press Ctrl Z, does that work? Yes. Okay, good. This line here extends the whole way. Okay. Good. We have the two things we know. We have the unknown. The big problem here is we have two VFs. That's a little bit of a problem, but we can fix that up. So let's rearrange it so VF is, all the VFs are over here and all the other stuff is over here. So actually I'm going to multiply both sides by VF divided by 2. And so you're going to get VF divided by 2 times VF. And that's going to equal delta D A bar. Well, VF times VF is VF squared. And if I multiply both sides by 2, then you're going to have 2 delta D A bar. So I did 2 steps there in one. Hopefully that was not too bad. So I can see I'm going on a bit of an angle here, but it should be alright. The last thing I would do is to get it so it's just VF. VF is the square root, if we take the square root of both sides, of 2 delta D A bar. Okay, awesome. That is the actual equation we're going to use to solve. So we've done all the hard work. We figured out the question. We've figured out how to manipulate all the equations. Now it's the dirt simple part. You just put it in the equation. So VF is equal to, we're going to put the numbers in. It's 2. Delta D is 3.50. And A bar is 9.81 meters per second squared. So that brackets 2. Alright. And you can use your calculator to find out what that is. And you should get something like this, 8.2867 meters per second. And we should have 3 significant digits because we got 3 in the question here. This one doesn't limit us, and this one's 3 as well. So because we're using a multiplication, it should be VF is equal to 8.2. This 6 makes the 8 round up, so that'd be 9 meters per second. That's the final speed. So if you drop the Sony Walkman from 3.5 meters above the sidewalk, it's going to be going at 8.29 meters per second when it hits the ground. Okay, that one took me about 12 minutes to do. I need to rescan. I wonder if I can do this. I'll either stop the video and do the next question as a new video, or I'll see if I can scroll down to the next one.